Hello. Hello, everyone. Hello, could you hear me? Because I could not hear you.
Now the right one.
Okay, let me see.
Yes.
Okay, great. Why you need to get into?
Porque ele mandou primeiro o.
This? You can't use in the pen drive there. Okay, got it. Kind of the company notebook. That's why I never.
Já recebi, já tá cá.
Good. Sounds good.
Depois tem que se meter a arrastar o fecheiro para um.
Já tá cá. Já tá cá.
Bom,
se eu faço segurança. Okay. We chair. I don't know his name. The chair of the session.
Just calling you.
Sorry.
It's calling.
We were in the wrong room, the wrong session. So we changed it to the C session.
Okay.
This is one was that we were in the room A.
Okay.
So now we have to ask if they hear us from here.
Okay.
Now we are ready to start the first session.
Yeah. Okay. I'll give you
Qual das duas vezes vai apresentar? Se posso saber. Qual das duas primeiro?
I'm not sure. Ask for digital.
Yes.
We start and let me see. Maybe they will arrive. It's time to
Hello.
okay.
Go. Share screen. Okay. This one. Now we can see the image from presented from there. This screen is showing, and now we put it on. Just
the camera's not being used, right? Just
no. Just as well. We're on sharing.
The camera's over there, right? The camera doesn't.
Yeah.
Yes, I will do that.
It's okay. It's alright.
Okay.
It's alright.
I need to click here.
Yes.
Okay. I wait for you here.
Yes.
Have the USB.
Okay.
I think you presented two.
Two papers.
Two papers, yeah.
Yes, exactly.
One.
I don't know, 4 for last one or something like that.
Okay.
My name is Silva, Flavio Silva.
I'm sharing the screen.
I think was I have it here, by the way.
We have the program.
Okay.
Yeah, but I also have.
No, okay.
I'm the first and the fourth.
Yeah. Okay.
First and fourth.
Well, let's start.
Okay. Got.
First, second.
Last. Yeah, all this presentation.
Yeah. Second for me. Okay. Thank you.
So we start.
My turn?
Yeah.
Okay.
So let while so let we start this session. So I will replace a colleague of me. So I'm sorry I did not read the paper before.
No problem. It happens.
Okay. So we start with Flavio, the University RAM, the paper, APO Digital, a flexible platform for smart surveys. Okay, so we are a little late, a little bit 15 minutes late. So Flavio, you have 15 minutes more plus 5 minutes question.
Okay, here's the problem here.
And the best is that you will sit there.
Okay, I'll do my best, okay? We're not taking all that time. Okay, so good morning. My name is Flavio Silva. I am here from the University of Minho, but it's a joint work with my colleagues in Brazil, okay? So we are presenting this APO Digital, okay? Well, so short summary here. So the point here is, well, when we look to surveys, okay, usually, well, we think on forms for Microsoft, Google, and things like that. So we're talking about traditional survey based on text, right? But now we're moving from these web forms to what we call the smart surveys, which basically is, first of all, we can use different environments such as smartphones and grabbing the data, wearables, and things like that. Cameras, so enrich this questionnaire. That's the point here. Well, this in this work here, we'll show an area, a domain area that we applied this is the area of post-occupancy evaluation, which is basically people from housing, from urban planning, from architects, they want to understand how people are using the environment, the houses, and things like that. So the point in such a situation is to combine the flexibility, usability, different flows. And so we're trying to move from this traditional surveys to smart surveys, and what we are presenting here as a category from that is APO Digital. What is the idea? Enable non-technical researchers build and deploy context-aware smart survey apps, okay, without custom software development. That's the idea here. So, oops. Well, so what we have here today, we have several platforms, okay, but they have some, let's say, they lack a broad support across the survey scenarios. So integrate this multimodal collection in one platform. So we have solutions, but one focusing cameras, other one focusing on sensors and things like that. So we're trying to put all this different data together. Also, we are also using generative AI to create new interactions with the respondents, right? Yeah, by the way, using a simple configuration from known programmers. So the idea here is to reuse the infrastructure, okay, to create domain-specific smart surveys, applications, okay? So it's a kind of a comparison with some related work. So we're here comparing these features, such as the availability of cameras. So the survey is not only answer something like, questions like you answer no, yes, or 1, 2, 5, but you take a picture, okay? Where you are right now? Well, I take a picture, okay? So camera. By the way, this platforms here, GPS. So can I integrate GPS information? Where is the respondent is? Some information like that. Moreover, we're talking here about external sensors here. So why not getting information such as, suppose I'm in a house, the temperature, the illumination on a room. Okay, I can ask to a person, oh, do you feel comfortable in the room? You can say yes or no, but I can also grab the temperature, for instance. Okay, so what we're trying to here are different, let's say, smart survey platforms, kind of comparison, and what we are presenting here, okay? So basically, oops. Okay, so this is the architecture of the platform, kind of a simple thing, but we are presenting here these different layers. So we have the several devices. The customer will use the devices. Okay, so we have a user interface layer. This is the platform. These are the devices. The idea is to have something that where the user has a good experience, user experience on different types of platforms. Okay, so browsers, mobile phones, tablets, and things like that. So we have a front end where the researcher, let's say, create this survey, okay, without no knowledge about programming or things like that. And what we create in the end, it's a kind of a PWA, which is an application that runs inside your phone or your tablet and that can interact with the sensors that is in that platform. So the guy creates this, and we have this back-end API that integrates, let's say, the database and services we have, such as Firebase, where we store images, Postgres, where we store other type of data, but also we have this integration with AI engine. So we use Replicate AI, so it's a kind of a service that allows us to use and test different models. And so the platform, depending on the type of the question, the backend will interact with this services. So this is basically the idea of the, let's say, of the user interface layer. So we have the user PWA, where is the answer itself, and we have the admin portal is where we created this service. As long as I created iSurvey, I have an URL. For example, this is an URL. This is the last part here. So if you click here, you will end up on a PWA application on your portable or on your phone. And the idea is, so the researcher goes to the admin portal, creates the surveys, create the different questionnaires, publicate this, and then the participant access that. So using these components here. Moreover, just to presenting here briefly, basically these are some layers we have in the architecture. The core design principle here was to separate this logical, okay, media storage, AI service, so because we have different flows here. So that was the main, let's say, guidelines we follow on the architecture. Well, here is some evaluation we did. So I talked about this post-occupancy evaluation. So these are real experiments we did in the field, okay? So this is done with my colleagues from the Federal University of Uberlândia. So we have this, so these are different applications. In the paper, we have the URL, so you can access these forms as well, the surveys, if you want, you can go there, you can answer it, okay? It's in Portuguese, sorry, okay? But it was used on different scenarios. This one is called, it's in Portuguese, but sorry, it's kind of my apartment, okay? So the idea is to get information about the apartment that people live. This one here is a kind of a more complex survey that it's not for apartments, but for housing. But also here we have some different, this is a very complicated, more complex questionnaire with different branching, different types of questions, not only information about the house, but information about sustainability habits and things like that, okay? And also we presented here, this is what we call the generic evaluation, which is, we just created a different survey on a very different area, okay? Using the same platform. So here is the apartment POE, housing POE, and here health, okay? So this shows a little bit how the platforms works. Just to show quickly to you some of the capabilities here. So what I have here is different types of questions. So we have this basic type of questions. So single choice, multiple choice, text input, things that we have such as in Google Forms, okay? But here I have some, what we say, advanced type of questions. So like this, take a photo that's something you consider important for your well-being. So it's a question, and the user answers with a picture, okay? This is what we call group scale. So we have different scales, and the person answers about different aspects. So kind of more complex. This is where we can do a ranking. So based on different questions, in the end, we can give a ranking to the user as well, okay? As long as so it's a kind of, we call it ranking questions. So this ranking questions is where the users answer several, let's say, questions of a section, and in the end of the session, it has kind of a punctuation. And then we can like do a ranking for him, okay? So this is the generic we created for. These are what we call the AI-assisted flows. So in the generic application here, the idea here is we call this generative AI image workflow. What is this? Take a photo here and choose what you would like to upgrade and things like that. So it's kind of an interaction. Use the image and the question itself. Here it's a different idea of taking a picture, okay, and identify things or information about that meal, for instance. So giving an idea to the user. So on this type of questions, we're also using AI to help us to do what we need. Well, so to conclude briefly, so what we showed, multimodal smart surveys, so adaptive navigation, no coding, so this PWA admin model, so that's what we're showcasing here, integrated with different sensors. So we showed this, these are some real use of the platform. So until now, we're just using with this, let's say, in this domain area for the architecture, but I'm pretty confident we can use this in several areas, as we showed here with that generic application, okay? So our next steps is large-scale user studies. So kind of more information about usability, complexion time analysis. We are working on that. So right now we are getting different metrics from the, so as long as we have the survey, we also added to the platform kind of a dashboard, and you can understand also what's time, how many time the user take on each question. How many, let's say, the user clicked here, there, and then he accepted one. So how many changes he did? So we're trying to get more information or more metadata from the evaluation itself. So what I presented here is this APO digital. So this provides a, let's say, a reusable foundation, okay, for richer, context-aware, and AI-enabled digital data collection. Well, thank you for your attention, and I'm free to answer any questions. Thank you.
So thanks a lot. So we have 4 minutes for questions in the room.
Thank you very much. It's very interesting. Maybe I will go directly to read the paper after, at least I'm really interested. And just a curiosity, how did you select the respondents for each of question?
Well, from this, let's say, these evaluations here, it was some, let's say, selected buildings in the area, in that city. They selected the buildings, they talked with the persons, and they agreed. Okay, so let's say the responsible for the building. So the group of the researchers, they usually send emails or something, send the links to them. So they after that answer and respond to that.
So are selected.
Yeah. So in fact, there are several studies, you know. In some ones, it's kind of that. We select and go there. Otherwise, we just, let's say, do some mass email marketing, given the URL of the let's say, the survey to grab information from different users from different places. So different situations in the platform. Okay.
Other questions?
Yeah, just one question. So I don't understand the frontier between the user answers the questions and AI mode.
Yeah.
So how in which way is it facilitated for the user to answer the questions?
The point here is kind of, let's say, create new interactions. Let's say on Google Forms, I cannot say to Google Forms, oh, take a picture of your room. Good. Now, would you like to change the color of your wall, of your walls? Okay. So we can do that in the forum. Which color you prefer? That one. Okay. So select the best color for you. You know, so it's kind of different, let's say, workflow we are not able to do today in tools like such as Google Forms or Microsoft Forms, things like that, you know. So it's a very, very interesting stuff we can do here. Okay.
Other questions before the last one? So thanks a lot for the. So would I? Okay, you use it for the as a server, okay? And as a colleague say, your workflow seems to go out from structured interview. If you look to that work on the way to the requirement engineering elicitation, where you have to say to you have to ask to the client what you want, and so that kind of stuff to me it could be used as a good tool in order to create a semi-structured interview where you let the client to elicitate some requirements that are very structured, like do you want the web page green or blah blah blah, and let the client define other requirements that you have not in mind. And I think that it could be used as a tool for requirement elicitation in a software engineering stuff.
That's interesting.
Okay,
it makes sense.
In that sense, you will give how to say you have a big theoretical contribution as software engineering development of the tool.
Yeah, sure.
If you turn back, you put that part at the first and not at the end of the evaluation of some stuff.
Okay.
Okay. It's just to me, I see how I could use it.
Yeah,
nice. my work.
Yeah, by the way, the platform is free to open and we can just, if you want, we can just set up kind of that. So let's try that. By the way, we are working with this group in Brazil. We are working there, but my goal is to reach different groups, different areas, in different domains. As you said, you know, requirement elicitation, we can do that.
Yeah, I think it could be. We have to
work
on it.
By the way, I think as long as we can show the tool to researchers, they will bring up or see, I could use this like that, you know?
Yeah, then another stuff, since we have 20 minutes, so it's quite exciting. The quality of the data. If I take you say about sensors, okay?
Yeah.
And I have a Fahrenheit.
Yeah, I see, understand.
And you have a Celsius 1.
Okay.
How you handle it?
Well, okay. By the way, in this case here, we are talking with, let's say, when we integrate with the sensors. Until now, we have, let's say, a set of sensors that are integrated to the platform, and that we are connecting to them.
Okay.
So we can, let's say, figure out how we can deal this right now. Well, we want to do this more flexible, you know. And maybe to interact with other sensors that you may have.
I can use mine.
Suppose that you have a sensor in your home. Okay, we have some standards. The problem is that we go to this IoT area. We have a huge, let's say, different protocols and different things like that. So we are kind of moving in this direction, but it's on our road, let's say.
Great. Thanks a lot for the presentation. So let us go to the second one. I think that in the domain of software engineering, it could be really a nice step towards the tool for this kind of semi-structured interview where you don't know. And since you have this kind of Gemini, LLM, could help the person in order to better explain what he has in mind, what the guy person had in mind. And I do it with my client. Okay. But anyway, and then I have to do this work. What does it mean?
If you want, we can try to set up kind of a
Just simulation.
I think that
simulation.
you got
Okay.
it's only a way to set the idea in another.
Yeah.
I got a question. You know better than me the work.
Are you LinkedIn? Let me add you here.
Yeah, you can link it in
I
me.
forgot my bag. Sorry, it's in my room.
Okay, so thanks a lot, Eduardo. Okay, Eduardo. So we have 20 minutes, 15 more. If we are late, so if you
Let's
can,
start.
let's start.
Let's shorten the thing.
Okay, let's go.
Okay, hello everyone. I'm a PhD student here at the University of Minho with a project for predictive framework in industry environment. And this article is part of the PhD project as a student. So it's about the quality of data, like you mentioned, in industry. It's very important before we go to predictive framework. So this is about a study in MSA strategy for end-of-line automated test equipment with no replicable measurements. The index, so we have an introduction, we have the end-of-line testing, context, experimental designs, methodology used, the case study, results discussion, and conclusions and future work. So, as in the introduction, usually MSA are important in order to avoid compromising the correct functional classification of products. For those of you who are aware of type 1 and type 2 judgments, so type 1 in industry is when there is a false rejection, the unit is good, but in reality is classified as not okay. Okay, usually. The type 2 is when we pass to customers a unit that is okay, and in reality is a real not okay. And in order to judge this every day, MSA, measurement system analysis, are important to every day. So that's the introduction. And now you can see also the classical measurement system analysis. In a typical classical MSA, the objects are static, the measures are static. So what goes differently is the tools for measuring, operators, etc. So, but the object of measure is static. It does not happen the same here on industry complex electronic systems like where I work, that and Bosch, my company, Active, Pre, all the other companies that produce complex electronic systems. So an electronic system, each time we measure something as a functional variable, it varies because of its software, because it starts in a different way the first time, the temperature on the environment, etc., etc. So it never gives the same value unless a static object. So that's why MSA for non-replicable measurement, because a circuit where we produce every day 6,000, 10,000 units per day, they never produce. We make power on and off cycles on the products, and we never get the same real measurement for that. So as you can see, a measurement is non-replicable when it violates the temporals. The values change over time, like in complex electronic circuits, and the object is destroyed. Is not the case, but it's a principle. So therefore, the consequence, it violates the classical MSA approach for a physical object or a standard classical method. Okay. Also a gap we found during the article. It was very hard to find articles who have this topic, even today. Okay, it is. So I have to check for more than 1,000 articles to find something, and even that it was not a specific article for complex electronic systems. There is no article, and it is a PhD. Of course, it's a challenge. Okay, so the present paper as a continuation of the work by me. I did a first article here. I presented an international conference last year, but we still lack some of data. We were in a learning phase. And also, the quality of data is our project, as the title of PhD, Manufacturing System Failures, Identification through Predictive Approach for Industry 5.0. So this is only a portion of the PhD quality. So the null hypothesis, my company, is assuming that there is no difference between independent and automatic test systems. We disregard the differences between the test systems. Okay, but I'm trying to prove that there are significant differences between ATE systems. So there are several methods in MSA. The classical ones here: the cross-fit design, the nested design. I will keep it short. The expanded design that overcomes the two factors limitation, because this is the most common used, crossed one, for reproducibility and repeatability, and the nested design also, but they are very limited. So we needed something else that would consider more than two factors and allow more flexibility together with a number. Okay. And other designs that for future works that were not considered in this article. Lattice square is a kind of design of experiment. Okay. Linear mixed effect model, type 1 based study, and fuzzy. Fuzzy, we do not get fuzzy in Minitab or PSS, SPSS, but we get through programming. I needed to get into programming to start on these methods. There is no other way. Okay. And of course, it will be maybe based on the next article. But for now, we stand for expanded design that we were able to use on this study. Then you have the equation that more than two factors. We have the test station, we have the nest. We will show you what is the nest, repetition, and the part. So there are more 1, 2, 3 factors plus the uncertainty. Okay, as an equation to see. So what we started, we tested the sampling plan. First of all, isolate the variant. The variant is the product. Okay, we use one product. The product should have the same hardware, the same software, because it will be produced computers. So to reduce the variability for measuring. So keep the same sampling homogeneity. Okay. So sample collection, we use 19 products devices in total. There are 11 benches, but for question of this was a study for the third shift. Only four benches were possible to use because of 8 hours third shift. There was no time for 2 more. And then we tested 3 times the same unit in each bench in each nest. Okay. Then it comes the variable selection, because for each unit we produce, we test dozens of variables in each unit. Audio, Bluetooth, wireless, you name it, lots of things. So many variables in each unit. So we have to select variables for the MSA. Okay. Then we have, to reduce instability, like I said, we use identical hardware software versions. Very important, not all the variables have the same part-to-part behavior, so we have to ensure a part-to-part dominance for MSA study. To select it in a method, to confirm the normal distribution according to IAG, it calls for normal distribution, we follow this, and calculate non-discrete category NDC. Of course, the NDC, the VDA, I defend VDA on this case because it allows for NDC equals to 1, like this variable, it allows provided the resolution of the equipment is at most 5%, which is met. So we use NDC equal to 1 on this variable. And among these several variables, we selected one that meet all the criteria. That is this, it is a digital audio variable. Okay. Now you can see the product. It's a multimedia product that we sell to Volkswagen Group. Okay. This is a bench. So there are 2 nests, and this is a complete rack. So 2 units measured simultaneously. Okay. It's nest 1, nest 2. This is the back side, and then this variable, the digital audio, it's the schematic. So there is a digital multimedia that is measuring this variable. The rack has a diadem and other measurement devices. So this variable will allow to verify the MSA and the quality of data on this particular measuring device on the rack. There are others. So this is unit 1, unit 2, and then we have a digital audio nest in each nest. Okay, so to keep it short. So as you can see, the first expanded with the 3 factors reveal that we have reproducibility and repeatability, a total of 36.5, which is inadequate because it should be less than 10% ideally. Okay, so you can see the variable has a part-to-part dominance, but the reproducibility and repeatability is bigger than 10%, but it's less than part-to-part. So we are able to here see 13%, 22%. As you can see also the sample range, what we identified in the first place, that the bench number 5 has a significant difference compared with the others, okay? So we are starting to see signs of reproducibility significance, which we needed to prove, okay? Also, you can see on the interaction plot, using the expanded method and ANOVA, that there are differences also on in the bench 3, 5, and the nests. These are the nests. So there are a big gap between nest 1 and 2, nest 1, nest 2. And these two nests are very close in measurements, and these two. Okay, so we start to see differences that were not noticed before. Therefore, the results discussions, the measurement system shows inconsistencies requiring attention. Investigate drift causes and review this particular digital multimeter, and the significant differences between ATEs and must be incorporated in future MSA evaluations. But there is a but here. So what do I propose on this article? MSAs in any industry is time consuming. It's a lot time consuming. Companies hate to do MSAs. That's the truth. You need to face it because they need to minimize resources. This took several weeks. They take hours to do a correct MSA. So the companies know they have to do because the customers require the quality of data, but it's time consuming. So the proposal that we do differently in this article is to do, of course, we will go time consuming the first time. Select the variables, okay, like we did. And on the second time, and third time, and fourth time, we know the variable, and we use more expedite tools. And the expedite tools is factorial ANOVA. We use this variable to compare the differences between systems. It's much more easy. We select the daily production and do this calculation. And do periodical calculation, because periodical calculation goes hand to hand with MSAs. The calibration has nothing to do with MSA, but they go hand to hand. Calibration, we already do it. But the main difference is to do factorial ANOVA with this, and this first evaluation, what are the variables, okay? Also, the conclusions. Of course, classical MSA are insufficient, it's proven. Expanded DRR with ANOVA proved a more robust alternative, like we proved there are differences between ATEs, which in our company it's not considered. We assume the null hypothesis, they are the same, there are no differences, it is not correct. Okay? And for the future, one of the things that we hear, refine MSA capable decisions, EOLs that are truly critical, because we can, with the factorial ANOVA from the second time onwards, identify every day on a weekly basis what are, with this variable chosen, what are the equipments that require more attention. It's more easy to do, okay? And also here, compare these metrics with claims from customers. Are these variables correlating with claims? Are we able to really protect, apart from protecting to assure the quality of data internally? Thank you.
Thank you to you. Questions in the room? No. So okay. No, but we have a few minutes. Just I was quite surprised that in that kind of domain, as you say, there are no papers, no, but patent and something like that.
Patent.
You know.
Yeah, I mean, Bosch has a requirement how to measure but has nothing to do. They did not even, it is in German. I read the specification from Bosch, but for instance, Bosch, they do not have even consider non-replicable measure. They consider the classical method. So I'm astonished, like a big company like that, they are not. Yeah. They are not. I know their requirements. Okay, I know my requirements. I know Bosch requirements. I read it, and I read 4 requirements, and I challenge you to look if you want to spend some time. But I look for over 1,000 articles today.
Okay, but
so this will be maybe the first article of complex electronic systems on MSA. I did not find.
Yeah. Okay, can you have you an idea of how many time you save doing your by hand approach or doing your applying your framework?
Okay.
I think that at the end
This is a question to put a dollar in the front. For management. Of course.
It is money.
Of course.
Okay.
Of course. Of course.
So because I think they do well think at the end.
Yeah,
Okay.
yeah.
I think that their measurement at the end are well done. But the question is how many?
Yeah.
How many time?
Yeah. This will take some time to prove it because I'll tell you why. Because this was done in a project that is mature project. And already we reduce claims along continuous improvement, Six Sigma projects, and so on. So in order to prove it, we need maybe 1 to 2 years to do this, apply in the company, and say to management, we are able to detect previously some drift in the benches, and we worked on time, and now from that moment we reduce the claims for X%, or reduce the if there is a step after this one internally, we reduce the problems in this step afterwards. So this is to be done. Because for management they have to have a dollar in front of them. It's logical. It's logical.
The day I think that I don't know BMW or Fiat, they do well measured.
Yes.
Intel. So the question is how is the
Sure.
that kind of proposal?
Yeah, I believe that I don't have any question that will be a cost benefit. The question is how much?
How much? Yeah.
How much? But there will be. I don't know how much.
This is the question. How much?
Yes,
how much?
there will be.
One
of the first questions, one answers to you is you save resources internally to make measurements. Because engineers take a lot of time in MSAs.
It is money.
It is money. So engineers, they do this the first time. If they do the second, the third, and the fourth, they spend 10 minutes and engineers go to their labs. So this is the first immediate benefit that is yet to be calculated, but that is. And then the claims from customer improving the quality.
That's great. We will wait for your paper.
Sure. There will be, of course, next articles that we will prove that.
Great. Thanks a lot.
Thank you. Thank you.
So the third one,
The third one is online.
Online?
Yes. The message of the chat. Okay. So I will.
You will.
Yeah, ask me to share the screen and put screen the. Hello, Ivan. Can you hear me?
Ivan?
Yes, hello everyone. Could you hear me?
Yeah.
Yes.
Okay, nice.
Thanks a lot to be there. I am Sandra. I will chair the session. So we are 10 minutes late, but okay, we have understood. Okay, let's go. You have 15 minutes more plus 5 questions. So let's go.
Okay, thank you. I will try to do all the best. That's why, hello everyone. My name is Ivan Ostrumov. I am from University Kyiv School of Economics, and I am a part of civil aviation team. That's why today I would like to present you our results in the navigational aids network optimization with the help of hexagonal geospatial indexing system. Second.
Yeah.
Okay. Yeah. Okay. What is the reason of that? If you know that on board of any airplane, we have several navigation equipment, and nowadays the most important one it is global navigation satellite system (GNSS). That's why most airplanes perform navigation by GNSS, which is mostly GPS system. In case if we have some problems with GPS, we will initiate inertial navigation system. However, civil airplanes could not use inertial navigation system for long period of time, because errors are accumulated, and that's why we could use it no more than 7 minutes. That's why for civil aviation, for common civil airplane, big one, I think 7 minutes, it is a critical time when we need to try to look for another positioning system. And in this case, then onboard equipment of airplane should switch to navigational aids. That's why nowadays navigational aids are used as a backup positioning capability for civil aviation. And there are 4 approaches which could be initiated on board of airplanes. That's why it is navigation by pair of distance measuring equipment, navigation by pair of angular-based or VOR and DME equipment, which called VOR DME navigation, and highly unwelcome configuration. It is 2 pairs of VOR or 2 pairs of ADF. Some airplanes are still equipped with this old equipment, and it could be used on board of airplane. That's why this is the logic of onboard equipment of any civil airplane. But what is the problem today? As you know, that Ukrainian airspace is suspended. That's why all air traffic is closed, and even more, all air navigation infrastructure is also frozen or shut down for more than 4 years. But the main problem that here you could see the map of GPS interference in the European airspace. That's why the red lines actually show the places where interference of GNSS equipment has reached civil aviation. It means that there are very wide areas when civil airplanes could not use GNSS. And because we have closed Ukrainian airspace, we have limited airspace of Russia. Also, we have some closed airspace in Iran and Iraq and Syria. That's why actually now all traffic from Europe to Asia goes through the Turkish airspace. That's why Turkish airspace, it's like a bridge between Europe and Asian countries. But as you could see, there are a red region. That's why in this airspace, pilots could not use GNSS for navigation airplane, but also the length of this jamming or interference is too wide. That's why airplanes could not use only inertial navigation system, because time of flight through the Turkish airspace, it's too long than 7 minutes. That's why in any case, civil airplane have to switch to their positioning by navigational aids. That's why the main point in civil aviation today, that's why we could not use only GPS or GNSS. We need to use additional navigational aids to guarantee the safety of civil aviation. And in this case, there are only 2 types of beacons which still available based on the Eurocontrol regulation. It is DME and VOR. That's why in this paper, we would like to analyze the network of DME and propose a new method for improving network configuration, because accuracy of positioning by navigational aids depends on network configuration. That's why if we have great network configuration, we have improved positioning performance. It means that on board of airplane, we know more accurate position of airplane. That's why there are two possible solutions for navigational aids. It is DME, but also widely used second system. Most functionality is still the same, but a little bit difference in parameter measurements. And another possible solution, it is angular-based navigational aids, which is called VOR. That's why I don't want to tell you about measuring principle, but DME, it is active system, which send interrogation, and then ground station will send reply signals. Actually, here you could see nodes of DME network in Europe. That's why most DME and VOR is a co-located ground stations. That's why here's a location of DME networks across the European airspace. And you could see they're part of Ukrainian chain of DME network. And in this research, because the Ukrainian infrastructure is frozen nowadays, some of equipment has been broken. Most of them be difficult to recover after 4 years unavailability. That's why we have a chance to develop a new network which will provide much more performance than it was before. And the accuracy of coordinate detection for civil aviation is calculated by the following formula, which called total system error, which includes error of piloting and error of positioning. That's why here we have components, mean standard deviation error of signal propagation in airspace and interrogator errors if we consider positioning by two ground stations. Here's the basic description of errors according to normative documents. For FTE, it is quarter of nautical miles, and for interrogator error, it depends on distance. That's why how far we are from ground station, it means bigger error we will have. Most available approaches and software which use optimization is grounded on simple grid model where we have linear cells. That's why we divide rectangular area with the small rectangles. But nowadays we have much more advanced approach, which actually my team use a lot. It is a hierarchical hexagonal spatial indexing system, H3 library from Uber, which help a lot with the navigation and data visualization, but also with the solving task like network optimization. Why? Because rectangular, regular hexagonal model has a lot of advantages because we could apply simple functions for disk calculation, and it provides us the set of addresses of cells which could be applied for example, for data calculation. The main idea of H3, it means that the whole airspace we could divide into the small hexagons. And there are 15 levels of precision, and here's the side of the hexagon. That's why you could see at the final level of precision, we could get approximately 60 centimeters side of the hexagon. And each hexagon has an address, and it means that we do not need to consider latitude and longitude, and are working with addresses and with their logical operations, not with calculation sine, cosine, and trigonometric functions, which we use in navigation, but working with only logical operation with addresses of cells. And in our research for this case, we propose algorithm like that, which at first partition required airspace for analysis into set of hexagons, then provide availability analysis, because each navigational aid, each node of network has a particular range of coverage. For DME and VR, it's not more than 300 kilometers. That's why around each node, we need to build availability map. And then by using TSC formula, we estimate accuracy of navigation for each hexagon based on particular level of precision. Based on this estimation, we provide compatibility of navigational aids performance for civil navigation. If compatibility is broken, it means that this is a broken cell, and we need to do something to fix the compatibility in this cell. That's why we need to apply reconfiguration of network to remove broken cells. And in this case, it should be iterative process. That's why we identify broken cells, and then we try to operate in the loop of availability analysis for network reconfiguration around these broken cells. But to perform that, we need to use a set of possible locations for new nodes. That's why as input data, we could just add, we have additional one node, and we have a place where we could install this node. That's why please find the best location for this one node. And in this case, we could apply brute force method to validate each cell in the disk of possible locations to apply the best location. That's why then we just calculate objective function for each cell and get effective beacon navigational aid location. That's why in this case, this operation could be binary. That's why we do not need to operate with accuracy in meters or accuracy in nautical miles. That's why we could just validate if this set is enough for navigation or it is a broken cell set. That's why we just need to operate with the broken cells.
1 minute.
Yes, and in this case, we use navigational aids, which we have in Ukraine. Then we develop a software in JavaScript with H3, and here's the result. That's why it is Ukrainian airspace. And here's a network which we have before network has been suspended. Then we identify regions in which we have broken cells, and then we apply simulation where will be the best location for the node to fill up the gaps of their network performance. And here you could see the result. And the color gradation here, it is navigation system error in meters. That's why from 500 meters to 1 kilometer approximately. And with the help of H3, we could not only analyze that, but we could calculate area. That's why here is a number of DMEs and percentage of airspace. And here is a navigation system error, and here is a percentage of airspace. And here is a conclusion. That's why the most important, which I would like to tell you, that H3 library could be useful not only for data visualization and aggregation, which we usually use, but it could be used for network optimization. It could be used for navigation application and even for positioning, because it saves a lot of computation time, because we switch to logical operation. There is no formulas, only one small formula, but then it will be only logical operations. And this is the main benefit for such approaches. That's why thank you. If you have any questions, I will be glad to answer.
Thanks a lot. So we have 3 minutes for a few questions, short questions. No, in the room. So my question is, but it should be fast in the answer. So why H3, and have you tested other index like GeoHash or I don't remember. I think
Yes.
there are 4 systems.
OLC from Google, for example. Yes, we tested, but why H3? Because there are 16 levels of resolution or precision, and this precision is very slowly changed. That's why you could easily switch between resolution. For example, you could run solving your task at some 6th or 7th resolution, and then if you obtain some results and you find some gap in the network, then you could choose the small region and run at the final level of precision, for example. That's why H3 propose dynamically changed resolution, the resolution level for calculation. OLC has a different steps between resolutions, and it could not be used for such case computation. GeoRef system with triangles, it also could be useful, but the size of cells could not provide the best levels for between switches, between precisions. Okay, something like that. That's why, from my case, number of resolutions levels here works at all.
Okay. And okay, this is the okay. I think that we must stop. Thanks a lot. We should discuss hours, but we have to move on. Okay. Really, thanks a lot.
Thank you. Thank you.
I'm the next.
Yeah. One and return, and then we ask the last.
Well, now I'm returning to the stage with a very different air. Okay, thank you. Well, this is a kind of work. I have a student where the point here is about ontologies, okay, which is let's say an area that has multiple applications, right? But we also face a lot of challenges for using it. So what we're proposing here is called a hybrid multi-logical reasoning framework over ontologies applied in the scenario, the domain of neurodevelopmental disorders. Okay, always click on the wrong key here. Okay, so this is my summary. So why bring hybrid logics? So the point is, we're looking here to narrow developmental disorders, such as autism spectrum disorder. And we have challenges here when we're talking about this area, but not only this area. In fact, we are applying this work here on this area, but we oversee that we can apply this in other areas as well, the approach. So what we have here, so we have heterogeneous data. So in an example here, we have some kind of different assessments and different information about reports from, let's say, from a child, from a parent, from a teacher itself, okay? So we have temporal evolution. So it's not a kind of static stuff, but it's something that's changed over time, right? Moreover, what we have here is some ideas. They're vague or they're uncertain, okay? So mild, moderate, severe. We do not only rely on binary classifications. Also, we have some conflicting evidence. So we have things, or we have some situations where we have conflicts. Also, we have normative constraints. So we have clinical decisions that involve ethical obligations and things like that. So the description logic, so based the ontologies, basically what we have here is web ontology language, which use this description logic plus the semantic web rule and language. They're powerful, but they do not support. So they have this binary logic limitation, okay? They do not have native temporality, so they cannot explain this kind of situation. They are inconsistent, intolerance to inconsistency. So classical reasoners, they fail to produce trivial results with conflicting evidence. They have no epistemic distinction, so they cannot differentiate things like possible commodity, necessary condition, and things like that. This concept, and also they miss this normative layer, so ethical obligations or informations that are applied or permissions that are applied to the system. So what we are exploring here is this idea of bringing different logics. We have an ontology called autism ONT, and the idea is to enhance it. So we have this framework that extends this ontology while preserving the capability with O2 description logic. So the idea is to use the hybrid multi-logic extension. So we integrate 5 complementary non-classical logic. So we're talking about fuzzy logic, para-consistent, temporal, model, and deontic. Well, we use this kind of a modular layered architecture. So the idea is you have the core ontology, then you have the logic extension, the hybrid integration, and then the application use that. So we separate these steps. We have what we call the hybrid semantic web rule language, which is able to cross inference between the different logics. And explainable provenance tracking, so every inference we can call the provenance, and so we did here also real-world validation. So this is the architecture, the overview architecture. So we have the core layer where we have the ontology, in this case, autism ONT. So we have this non-logic extension layer where we add this 5 different types of logic here. Then we have this hybrid integration layer, and the application itself will consume these results. Okay. Well, so the point here is talking a little bit about this architecture, but not taking too long. So I'm talking about this unified meta reasoner here. So what is that? So the central, this is the central orchestration engine here that unified the classical O2.0 reasoning with this 5 non-classical extension. So it parses incoming age SLR rules and queries, decompose them by logic type, dispatch the subtasks to the parallel extensions, collect the results, and then make a synthesis of that. The HSWR, so hybrid semantic web rule language, it's an extension, that brings and allows to put together these different logics here, right? So what is the let's say, key innovation here. So using what is we call the HSWRR, so we can use this cross-logic inference. So an example here, I can have a fuzzy-graded severity, something like that, which is fused, para-consistent evidence, a temporal window, a model possibility, and a dialectic obligation here. So we can put this all together in a coherent way and work on top of that. This is the meta reasoner, the algorithm. So basically how it works. So the algorithm starts with the sparse and identity. So it identify the type of logic. Then we have this delegation phase to dispatch this to the different extension reasoners. Then the classical reasoning, which is there in the core, the synthesis phases, and finally the conflict detection and integration. Well, so this is a kind of a scenario presented there in the paper. So it was a real person that was, we used that information or the data grabbed from the situation here and applied in the scenario, right? So here presenting a little bit the situation here. So the hybrid processing, so we grabbed from the different information we had in the situation here. And then what was created on top of that is a kind of, let's say, personalized care plan based on the data and information that we have. That was like in the real world here, right? So some key contributions here. So first 5 logic hybrid framework. So using this approach, this full backward compatibility, because we're also just adding in the core layer. We have this HSWRR cross logic inference here, and the explainable and provenance aware. So we can complete a fully understanding after that. And this real world validation. So some limitations in future work here. So current limitations, because we have this, we have a kind of, let's say, as long as we have a big data set or something like that, so we need to optimize this for just large scale deployment, okay? Today, fuzzy membership functions and evidence thresholds, they are relying on expert input. So we need to have this information at this moment. So this obviously impacts on large scale users and things like that. So we would like also to increase this validation, okay, in the system. Well, so future direction here, integrate this maybe with ML pipelines for automated parameter optimizations and rule discovery, extension to other, eventually other neuro disorder disease. So the approach here can be applied in other scenarios, maybe integrate with systems, AR systems, and data-driven refinement on this fuzzy logics. Well, so concluding remarks. So the HML autism bound so demonstrates that this idea of this principle of integrating non-classical logic can bring a more expressive, feasible, and clinically powerful knowledge representation from the system. So the idea is to address the core limitations of descriptive logic ontology and bring this in this domain here of the neuro disorder disease. So it enables this nuanced reasoning, okay, over graded severity, temporal evolution, so conflicting evidence, epistemic uncertainty. So the idea is to enrich the system on that. And this modular architecture really help us to bring it, to deploy it, to evolve the different parts. So kind of a scalable thing. So as I said, we open here this new avenues for this semantically rich information systems, okay? So bridging formal knowledge, representation, and this complexity that appears in some systems. That's it. Very different area of what we're talking before, but now we're reasoning about this ontology stuff.
Questions in the room?
Just a curiosity about the context of this research, because it is very clear that out of this complex technical system, you have also a collaboration with some doctors, because for me, creating the ontologies.
In the paper we acknowledge because there's a team of experts before here behind us, so we are talking, we're in touch with them.
Is this a project or just a research?
It's not let's say, it's a student that I have, not kind of an European project, not that way, but it's a project that we have, we're working with this institution. It's a real institution, a real clinic, and stuff like that. You know?
Okay, thank you.
Okay, so your HS, this work language, is based on what is it? Like a Sparkle, like what?
You mean this hybrid semantic web rule? You mean?
Yeah, this language. How you query your? If I understand, you are able to query the ontology.
Yeah, but the idea here is just put together just different logics here, you know, in expressing this. So as long as we have this, in fact, it's kind of having, like, you have the ontology, traditional ontology, but then you can add that information, you know, this data is added, and then we can, using the different reasoners, prepare for this different type of logics here, you know, so we can interact with that data. That's the point here.
You know, miss it. No, sorry. You see that how do you query your ontology? How you?
Well,
this is the question. You have the ontology with the you say, give me.
Okay. Yeah, it's kind of like Spark. Yeah, you said like Spark and things like that, right?
You can. Yeah. We use Sparkle.
Yeah. That's it.
Okay, and Spark is able to understand this fuzzy and stuff.
The point is that we have this, let's say, this reasoner here, okay? So we have these different extensions here, these reasoners that help us to kind of understand that. So we can model that and understand and treat that and put that all together. That's the point here, okay?
And this is quite a strong question. Only to open some vision. Okay. So I've seen some papers where people use property graph.
Okay.
That seems like a lot to the ontology, and behind on top of that they use LLM in order to infer, to query the data, and they're able to infer really complex.
Okay.
I don't know if can be
applied
another way to proceed, because this kind of graph on ontology are very, very, very similar to property graph that can be used with LLM.
Okay, well, that's maybe an interesting path to check, maybe. Yeah.
Guy from AI, a person from AI would say, why you compare with Prodigy or something?
Yeah. Okay.
You just to
open,
maybe or not, another channel. So thanks a lot.
Okay,
and we go to the last slide, and we are more or less in time.
Change again.
Change again, yeah.
Okay. This is a
This
very
paper was submitted to workshops entitled governance of energy transitions, environmental landscape, social and spatial planning. So we are in that field.
We are old, we can.
yeah, that's right.
We try to.
I mean, it's not a paper for a general trial.
Okay,
So, good morning, everyone. Today I will present the first preliminary results of SUSTAGE project. That is an interdisciplinary research project that investigates how energy transitions and demographic transitions can be addressed together in rural and mountain areas. My co-authors are part of the SUSTAGE team from Politecnico di Torino, and Giorgia Malavasi is here with me.
Great.
And so let me introduce briefly the project. SUSTAGE is funded through the Italian Ministry of University and Research under the Department of Excellence program. The project runs from 2025 to 2027, and it's coordinated by Professor Mola at the University of Torino. So we are working together, Politecnico and University, and also brings together different expertise from law, architecture, we are architects, energy engineering, systemic design, and economic evaluation. Specifically, George and I are from real estate appraisal and economic evaluation. The common objective is to explore how renewable energy communities can contribute not only to the energy transitions, but also to improve home-based care and active aging in fragile territories. So my presentation is organized in 5 parts. We'll introduce the conceptual framework and explain why we believe that green and energy transition should no longer be considered separately. Then I will present our methodological approach, the case study that is a rural area in Italy, in Piedmont. And finally, we'll discuss the main results and conclude with some reflections on the role of REC, renewable energy communities, so how they can support territorial resilience and social cohesion. So these two. Well, I think that we all agree that climate change and the demographic aging represent 2 of the most important challenges for European territories. So on one side, we have the green transitions focusing on REC and renewable energy systems, decarbonization. On the other side, we have the great transition, characterized by population aging, welfare, an increasing demand for welfare services, and growing socio-territorial vulnerability. Although this process occurs simultaneously in many rural areas, they are generally studied through separate disciplinary and policy frameworks. So our starting assumptions is that they are actually deeply interconnected and should therefore be analyzed together. These interactions become particularly evident in fragile territories. So aging population generate new needs for healthcare, mobility, and proximity services. And at the same time, renewable energy communities create opportunities for new forms of local cooperations and shared investments. Rather than considering energy infrastructure only as a technical issue, we propose to investigate how it may also become a social resource, able of supporting local welfare systems. So, starting from the literature review, we identify an important gap. Most of the existing studies focus either on demographic vulnerability, welfare accessibility, or renewable energy potential, but very few studies integrate these different dimensions. Also within the spatial analytical frameworks work on the territory, so it's very narrow. Therefore, the first phase of this stage project, so project is still ongoing. For this first phase, our objective was to develop an interdisciplinary GIS-based methodology able of integrating different kind of data sets and identifying synergies and mismatches and supporting place-based decision-making process. Our methodology combines two complementary domains. The first concerns the gray transitions and include demographic information, welfare services, and social vulnerability. The second concern the green transition, so including renewable energy potential, energy infrastructures, and renewable energy communities. All these data sets were integrated in GIS environment, of course, and demographic, social, and energy data sets were combined and integrated in a common spatial framework. This allowed us to move from isolated analysis into systemic understanding of those territorial dynamics. This is always our starting point in every project. So these integrations made it possible to compare information that usually belongs to different domains and disciplines. We are many 3 or 4 disciplines together, so different points of view, and so very difficult. So we start managing different kinds of data, integrating them, and start a debate and interdisciplinary dialogue for territorial planning as very first phase. So the integrated database is then interpreted through a SWOT analysis. This is a very simple method, but very useful to debate. And so we applied and developed in a participatory manner. I will show you. And this allowed us to identify, of course, trends, weaknesses, opportunities, and trees emerging from the combined analysis of demographic, territorial, and energy dimensions. The SWOT, therefore, acts as a bridge between quantitative spatial analysis and strategic planning, so a more qualitative approach that will be carried out in the future months. So our case study is the northwestern Canavese area in Italy, in Piedmont, a mountain territory that presents several characteristics that makes it particularly suitable for our research. It has low population density, significant demographic aging, increasing accessibility problems, and fragmented settlement structures. So, very important and significant for us that it has both a green community and a renewable energy community called Fervores. So it provides an ideal context for analyzing the interactions between social and energy systems. Looking at the first preliminary results, as I mentioned, the project is still ongoing. Looking at the green transitions, we found that the territory was favorable, as favorable conditions for renewable energy production, and the Fervores already covers the entire study area. That's good for us. While on the other side, significant funding has been allocated through the National Recovery and Resilience Plan. But there's a but. The renewable energy potential is especially heterogeneous and required place-specific strategies to be adapted to local conditions. Moving to the gray transition, so from a social perspective, the situation is more critical. Population aging is widespread across almost municipality. Accessibility to healthcare and welfare services is uneven, especially in mountain areas where public transport are limited. And so these preliminary findings highlighted also the importance of strengthening home-based care and proximity services as key components for future territorial policies that we are going to face. So integrating the different database within the GIS, we obtain a rich understanding of the territorial dynamics. Most of us even know the territory at all, so that's important. Instead of analyzing the demographic, social, energy information separately, we identified spatial relationships that would otherwise remain hidden somehow. The GIS became a knowledge generation platform supporting interdisciplinary decision makings, and I'm sure that will also support the next future phase of the project, where we are going to interact directly with the stakeholders of the territory. So other highlights, the demographic aging and the energy vulnerability often coincides. Renewable energy investments do not always align with areas of greatest social demand, very synthetic outputs. And finally, the renewable energy communities emerge as a potential enabling communities capable of supporting both energy production and innovative welfare services. So let's say it's confirmed our research. Very briefly, the SWOT analysis was developed in a participatory manner, and it was very useful to integrate disciplines, to debate, and also interact and summarize some key points. By now, we decided to just extract very brief results and related to the energy dimensions and specifically the energy-related social aspects, and also on social healthcare dimensions and the organizations of care services that highlight that coordination among them remains very, very limited. And the structured data for service planning are still not sufficient at all. So it's a very interesting gap for us to move on with the other phases of the project. So on one side, we identified critical mismatches, aging, poor accessibility, energy poverty, fragmented services, and on the other side, we identify potential synergies. So renewable energy communities can support welfare services, community hubs, and decentralized governance. And our key message by now is that renewable energy communities should no longer considered only as an energy infrastructure, but they should become social infrastructure, supporting the territorial resilience of those fragile territories. well, the project is still ongoing. I think it's clear, and the next phases are briefly summarized in this scheme, and we will focus on co-designing the integrated system with local stakeholder. We already identified one of them, that is the consortium, and we will develop a theory of change and will define measurable indicators to assess social and territorial impacts. And let's hope that this activity will progressively transform the analytical framework into an operational governance tool, so useful for that consortium, but also the municipality of the territories. So to conclude, our research demonstrates that, well, this is a very not unexpected results, but integrated spatial data allow us to identify both synergies and critical mismatches across those fragile territories. This analysis provides stronger evidence from place-based strategies and more informed decision-making process. And most importantly, they suggest that future energy planning should be developed together with welfare and territorial planning. So our message is that we think that renewable energy communities have the potential to evolve from simple energy infrastructures into social infrastructure, able to strengthen social cohesion and territorial resilience. So, thank you very much.
Questions? Okay, a lot of, because I have not understood so. But you say that when you combine the layer of the GIS, you see that there are some spatial correlation or not correlation. And what can you explain to me what are these spatial correlation between the energy renewable stuff and the old age people? What they are? What is the conclusion? They are far. They are. I didn't get it.
Sì, no, anche.
Questo è passato veloce.
Sì, è andata veloce. Yeah. Yes, here we basically confirmed that those kind of territories are fragile from a socio-demographic point of view. So aging populations of very young peoples, lack of young peoples, but is also combined with the energy poverty. So all the families and the people living there have a lower willingness to pay, and also possibility to spend money for managing systems or simply pay bollette. I don't know, bills of energy.
Yeah. Because it is the classical, the traditional energy provider.
Yes.
And so if you change with new electric provider, the bill, the money will be, this is the question. Is the green less expensive of this one? Because you say me that the problem is that they have no money.
They have no money, but I think that the point in this in this context is so the challenge that renewable energy communities launch, but they are in some context they are a sort of fake contract. So they promised, I don't know how to say, they promised to be very fruitful and with a high potential of profitability, so for citizens, but
It's like in the agriculture,
yeah,
it's not.
yes,
It's not useful.
I say for joking, like multi-proprietà approach of years ago, you know, and so people are convinced to join the renewable energy communities, and now they cannot act as a real provider or well, consumer yet, not provider.
Yes.
Yes, I didn't mention all the systems of the renewable energy communities, but the point is to provide energies and learn from selling energy. So, Giorgio, if you want to add something,
yes, just to answer to your question, in this context, this is a particular context because there is a problem in the orography. So we have all services you can see from the map that are in the area that is the less plana area. I don't know how to say. And then we have the part with an higher altitude on the left of the image. And if you go to the next slide, well, no, sorry, the previous, okay. This is the map with the energy potential analysis, and you can see that the most problematic area are not covered by the energy provision. So this is a problem, but in this area is very particular because we are in contact and we are co-designing with healthcare consortium that wants to not only give money, give funding for solving healthcare problems, but wants also to provide something for energy poverty and for creating energy projects. So this is the match that we are going to straighten.
All the projects are very spread, and so we have to play a role of support university as a support team for real stakeholders in managing this challenge.
No, thanks a lot, and I think that is the last paper.
Yeah.
Thank you.
And we move to the break. Take the break.
Yeah.
Giusto, erano però troppo diversi gli interventi e anche per me è difficile fare domande così.
Ci siamo riusciti?
Sì, sì.
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 I proceeding sono tutti nella piattaforma.
Come?
I proceeding sono tutti nella piattaforma.
Ah, sì, esatto, arriva sempre prima della fine.
Sì, no. Ma quella è la parte più dura.
Ce lo dicevo anche ieri Chiara.
No, quella è la parte più dura perché ci sta comunque la questione. Voi siete stati, dicevo, voi siete stati precisi, quelli che mandare i messaggi. No, però l'altra sì. Perché lasciami una settimana, poi posso mettere, poi posso farlo. Allora fai l'ultimo volume che devo mandare l'ultimo, c'è, però.
No, quest'anno abbiamo rischiato di andare fuori di testa, ma noi perché abbiamo esagerato, perché sì, come detto noi non siamo tante, ne abbiamo mandati 6. Quindi abbiamo detto oddio.
Una situazione no.
Abbiamo fatto il progetto.
Ma quella cosa di che è chiusa possiamo rubarla?
Sì, se è chiusa sì, se non serve.
Sì, no, spero che sia chiusa, se no non la tocco.
No, li vengono a mettere qua normalmente.
No, me l'ho anche detto che è piaciuto un sacco ieri.
Sì,
Bravo.
Sì.
Proprio parte
sì.
ma qui il tema.
Sì, sul tema che tutto sommato sì, però ci interessa poi un'ottica più su questioni di organizzazione aziendale.
Sì, però poi lo scarico.
No, ma adesso quella cosa di questa conferenza che tu senti della roba fatta da una cosa che fanno tutt'altro rispetto a te, però ti viene un'idea.
No,
Sì,
esatto, no, ma infatti anche chiaramente la sessione comprati oggi tutti dire degli interventi che non avresti scelto, no? Perché,
Sì.
però hai ragione, cioè,
No, ma questa è l'idea che era partita. Tu mi hai vista la tua presentazione?